class 12 physics ki unit number 1 electrostatics ki chapter number 2 ni electric field. So first we have to define electric field. Electric field se kari no fargadi saigi charge amagi akoi bida leiba saigi jaga ni karba jaga no fargadi atopa charge ama pusalakbada saigi electrostatic force pi bangam ba oigadaba karigumba electrostatic force pi bangam draba jaga do khoina electric field ko ba yade awna khoina electric field se kamai define to ba yage bu the space or the region surrounding the charge in which electrostatic force can be experienced by any other charge, or it may be defined like this: the space or surrounding the charge within which electrostatic force can be experienced, or the region in which the other charge can experience electrostatic force. So we may define like this: say electric field the space or region surrounding a charge in which electrostatic force can be experienced by any other charge is called electric field. Electric field. Hala sigi electric field ja koina ani thongna muk khaitokpa yai uniform electric field haibama non uniform electric field haibama. Uniform electric field hairgadi hairiba electric field duda akoina lawningba point lo matamda magi strength mapangando electric field gi strength to samana baduni aduga manadragana non uniform electric field kawi aduna electric field ja koina uniform electric field haibama non uniform electric field haibama smaina ani to na khaitokba yai adu mokoi define tawji. Electric field is of two types. Roman number 1, uniform electric field. Other uniform electric field, it may be defined like this: an electric field at every point of which has the same strength is called uniform electric field. Uniform electric field. Aduna hairiba field duda leiriba point khudimak se magi mapangan haitare electric field gi strength se samanragadi akoina uniform electric field kawi ado akoina graphically kamaina represent tabudagi fargadi maje parallel and equispaced lines na represent obo yai smaina akoina lines se parallel oina yeba arrow lines aduga line amaga samanaraba lapaje adutadi sigi arrow lines na style je uniform electric field ni sida sigi figure is na tai je ko electric field se koina capital E na ju represent tawi anu si je uniform electric field. Uniform electric field gi representation ni electric field sigi figure silere. Next up, non uniform electric field. Non uniform electric field hargana hairiba field duda akoina point khara lawraba point sing duda magi electric field strength se manadragadi non-uniform kaudini. So we may define like this. Second is non-uniform electric field. Aduna non-uniform electric field je akoina says might find the way an electric field which have different strength at different points is called non-uniform electric field. Non-uniform electric field. Graphically, combine represent the widagi fargadi. Akoina non-parallel arrow lines wagera natragana parallel waragasu unequispace oi bhaitar line me amje lapa banadaba natragana parallel oidaba hariba figures ina non-uniform electric field je akoina represent to bayai. So these are the two types of electric field. Mathang da laktu is now how to find out strength of electric field. Ato akoina kari ka weda electric field intensity jo high or electric field strength so high or simply electric field ka khair jo koina khangna gani on electric field intensity je amu define to jeba. Electric field intensity denoted by capital E. Ado maja ko vector quantity oigani direction jagoni on arrow pbi ismaina. Ado my definition la tringaida so ina figure am ko yengsi say let Q represents a charge. And sigi matang ja ko na charge se source charge haiba ma te charge haiba ma ani tong na leba yai. Source charge hairgadi the charge that can produce strong electric field or electric field fazana produce obangamba aduma charge koina source charge haina kawi aduga te charge hairgana yamna pick pa charge ogadaba aduma ma je positive charge oigani. That is a te charge should be an infinitesimally small positive charge yamna pick pa aduga positive charge noina te charge haije sagi source charge to gi electric field gi mapang adu test of the season aba awna sidalari ba q ja koina source charge so hainai that is electric field fazana produce obangamba ar magi field manungda electric field manungda point am lawraba p haiba points lower se. Then how can you find out electric field intensity at point P due to charge capital Q? Sigi charge capital Q jigi P de laiba electric field intensity je kamaina measure tawudage kamaina putokadage haibani auditardi sigi P ji da koina unit positive te charge 1 coulomb of charge ama thamaba moi je koina unit positive te charge su kawi sigi 1 coulomb of charge da sigi capital Q haiba source charge na P ba force to neba koina electric field intensity na phairize aduna suppose koina any sigi te charge se 1 plus 1 coulomb gi mota koina q naught ana lawraba te charge q naught it should be a small charge ni ko yam pick pa charge ni sigi te charge da p ba force se capital F oraba. Here F represents force exerted on a test charge due to charge capital Q, that is source charge haije adu da khoina pamidi 1 coulomb of charge da piba force to neba and that is called electric field intensity haije ni awna sigi test charge se 1 coulomb of charge oitargadi what will be the electrostatic force. Then yamna simple oiba khoi unitary method palakanda sigi 1 coulomb of charge da piba force se F divided by Q naught ana lakaneba. Q naught the piba force the F oitardi 1 coulomb of charge ki oitardi F divided by Q naught haiba. Adu sigi formula jineba koina electric field intensity ki formula oidoje that is force divided by T charge. Ana koina definition je kamaina piba yagadage bu electric field intensity at a point due to a charge is defined as electrostatic force experienced by a unit positive test charge placed at that point have yai. Akoina field dugi manungda T charge ama thamaba 1 coulomb of charge aduda ngasagi akhoi source charge na pure force tu ngasagi source charge tu gi electric field intensity oigani hariba point du da awna my definition just might be yai electric field intensity at a point inside an electric field is defined as the electrostatic force experienced by a unit positive T charge. That is, we may write plus 1 coulomb. Place at that point. Sina electric field intensity gi magi definition ni ana mathematically combine pi ga dege phai tardi yengse muka say let capital F vector be the force, that is electrostatic force exerted on a T charge Q naught. It should be an infinitesimally small positive charge ni or yamna pick pa charge ni Q naught se and Q naught the force F ni the low ni F be the force exerted on a T charge Q naught placed at a point inside an electric field. Say due to a source charge. Let us say capital Q. Then electric field intensity at point P is given by capital E vector equal to force divided by T charge. The formula is electric field intensity magi basic formula ni, that is force experienced by a unit positive T charge. The formula is modified or we may write like this: electric field intensity equal to limiting value of force F vector divided by T charge Q naught, where Q naught tends to 0. And electric field intensity at a point limiting value of force divided by T charge, where T charge Q naught tends to 0. Meaning T charge Q naught say yamna pick kadavani haibani, that is tends to 0. Magi value 0 yam nang kadavani na adugi meaning is the period. Aduna simply E equal to F by Q naught. Natragana spinal period E equal to limiting value of force divided by Q naught, where Q naught tends to 0. Smile later. Next up, SI unit of electric field intensity is Sigi from last day lakpayai. Now F higher the force ni, that is Newton, charge higher the coulomb ni, aduna SI unit of electric field just might be its SI unit is Newton per coulomb. Aduga माजे vector quantity ni direction lai ko aduna mai direction je kadom da sakadagi phi tardi ngasai khoina source charge ama lai re source charge tu imung da point ama magi field du imung da point ama loroni hai ba point du da electric field intensity gi direction je kamaina putokadagi far gadi point du da khoina 1 coulomb of charge natragana ts charge ama thambaba adugi ts charge tu na mana satliba natraga satningiba direction amadi laineba electric field manungda adugi direction duna electric field intensity gi direction oineba ko for example sida source charge ama laire magi field manungda khoina point ama laure sida point p sida khoina ts charge ama thame q not hairasi or it may be 1 coulomb of charge or su kaide adoi tadi sida laiba source charge positive charge ni siju positive charge ni positive de repel dobni na sigi q not ta pi ga force ya minus ka doine ba anu sigi direction sida sigi q not su sunning doini aduna sigi sunning iba direction jine koina electric field intensity gi direction oi duije aduna my direction is my pvi say it is that is electric field intensity is a vector quantity which is directed along the direction through which a unit positive ts charge placed at the point or at the given point tends to move or moving inside the electric field aduna sagi sida harise electric field intensity is a vector quantity oire which is directed along the direction through which a unit positive ts charge placed at the given point tends to move or moving, or you may write say moves ko tends to move or moves inside the electric field sagi ts charge tuna satningiba natragana mana satliba direction do aduna electric field intensity gi direction oiganeba ko ojik laktoi mathang da laktoi na electric field intensity at a point there in terms of source charge and distance of the point from the source charge sida koina mu express the way aba hojik piri jina force divided by ts charge na basic formula le next ta laktoi jina electric field intensity je akoina source charge capital q ga aduga akoin loriba point duga source charge ga lapdariba distance duga aduda mu express tawse ko electric field intensity due to a charge how the see figure je dum lo ba yai sida khoina source charge am laire bagi field manung da point am laure so here r represents the distance of point p from the source charge and q naught represents a ts charge which is placed at this point p when the ts charge am sigi point p da thame adoi tardi sigi point p da leiba electric field intensity do in terms of capital q and capital r ga da p se ko aduna sida smine irani let us consider a charge capital Q. P be the point at a distance r from capital Q inside the electric field. Now, sida koina source charge am laire magi source charge ki field manungda point am laure p saiba point p ki pai ara pajan r oire aduna next laudui je sigi test charge p da leba test charge q not sida si capital Q is na p force na irasi the electrostatic force exerted on a test charge Q naught at point P due to charge capital Q is given by Q naught sida capital Q na piba force to the Coulomb's law apply to kanda smai PBI F vector equal to product of the two charges divided by 4 pi epsilon naught r square smai pirani direction di away from the source charge haidi sigi source charge to positive ni sigi test charge to positive ni and positive repel to bunina sida piriba electric field intensity na chaliba direction siga force ki direction samanani maram the repulsive force lebanina adu sida my direction is might happen yai directed away from capital Q and write it equation number 1 so my PBR audi test charge the piba force to khangabanina akoina electric field intensity at point P je akhoi ngasagi basic formula sida leriba formula se apply toroga putokpa yarani awna sidi ngasi therefore electric field intensity at point P due to charge Q is given by capital E equal to force divided by TS charge. और इसी दफा ये force है unit equation number 1 द पीरियड force की मागी value जिस सिंजलो अदुगा सिगी Q naught सिदा लेबा Q naught सिगा मखा लेबा Q naught से cancel चर करनी अदुना स्माइल लानी Q divided by 4 pi epsilon naught r square sigi Q naught siga force the yariba Q naught siga cancel चर करे अदुना asagi electric field intensity की formula je in terms of source charge and distances smile rani Q divided by 4 pi epsilon naught r square direction di asagi ngasai akoina force ki piba direction samanani that is directed away from Q dum haiba yai my direction je directed away from aduna asagi electric field intensity at a point due to a charge capital Q je magi direction se kadom da sakadage bu sida lere sagi sigi test charge siga sigi source charge siga positive marktani na sigi test charge se tends to move away from this source charge sida period ni ko source charge dagi lapthokina ba khonara ne aduna smile iba yare directed away from charge capital Q smile period my direction se aduna sigi formula je akoina calculation kumba hot pada ju yamna season arkani aduna si khangdabi ade yamna maru oiba formula ni sida lerise aduna ngasagi hojiki electric field intensity dugi matang da exam da lakpa question je smaina 2 mark kumba da smaina hangpa yai se question je define electric field intensity mention its SI unit. 1 plus 1 equal to 2 mark of this minor hang bayai or mathang da lak tu china electric field lines or electric lines of force on the electric field lines se kari no mu define do je ko or next lak tu topic china electric field line natragana electric line of force so hai bayai on the electric field line hargadi akoina it may be defined in different ways tongan ba way da akoina define to bayai se akoina definition je la tringai da figure of yengsi let us consider a charge. It may be a source charge charge ama laire magi field manung da akoina point ama loraba sigi charge ki magi field manung da point ama lore point p sigi point p ji da akoina 1 coulomb of charge unit positive t charge harise 1 coulomb of charge thamaba ado sigi 1 coulomb of charge na sigi field manung ji da satliba magi lambi du ne part hai tare ko lambi du ne koina electric field lines harise to wudabu sigi t charge se atopa force of the piba yade maje free da thamgadabni mapalom dagi maje force amata ek to ba yade aduna electric field lines akoina kamai define to ba yage bu sagi the path along which a unit positive charge moves or tends to move inside the electric field. It is free to do so. On the masagi charge na electric field manungda yam free oina saliba lambi dunia ba koina electric field line side. Natragana atopa definition na electric field line se kamai define to ba yage bu maje imaginary line in the lower inside the electric field akoina wakana sagat pa mas line ne ba tawudabu hariba line du da akoina point ama lawraba point du da akoina tangent ama draw tawraba tangent ama yeba tangent na chaliba direction do electric field intensity ki direction oigadabane ba adu itardi akoina loksaliba imaginary line do electric field lines haibada adum yare aduna electric field lines akoina smaina define to bayai it is defined as the path lambi ko the path along which a unit positive charge tends to move or moves inside an electric field if it is free to do so. My definition is natragana or it is an imaginary line straight oigera curve oigera oining bo oirsanu it is an imaginary line such that imaginary line inside an electric field such that the tangent drawn at any point on that line will give the direction of electric field intensity at that point aduna sida hari jakoi line amita lawre basmaina electric field manungda sigi line sida koina point am lawra basmaina sigi point da koina tangent am draw ne toraba adui tadi direction of tangent sina sigi point p da leba electric field intensity p ragadi sigi line jakoina electric field line ko ba yare haibani next tab lak toisna magi properties of electric field lines exam da dum hangba yawi si properties write 2 properties or 3 properties of electric field lines and ko hangba yawi auna mathang da lak toisna properties of electric field lines se mu yengsi properties of electric field lines. Electric field lines koina electric lines of force har su yai ko malera ana first properties e ama ahan ba properties karino bu electric field lines sing se positive charge oiragadi positive charge ta giloina thorakani aba negative charge oiragana magi electric field line se negative charge mu loina changjalakani aba ko aduna koina sumaina haiba yai electric field lines are directed away from positive charge and they are directed towards negative charge. Akoina figure ni yekto kya hagan isma yekpa yai positive charge am lawraba altad mag electric field line se kama yekadage bu isma ni yekpa yai positive charge oiragadi electric field line se charge no giloina tholakani aba negative charge oiragana minus q oiragana electric field lines ki my direction je charge from the changjalakadaba smaina smaina khoni yektar aro sagi exam the questions smaina lakpa yai draw the electric field lines of a charge curve charge greater than 0 natragana less than 0 na harakane abko and greater than 0 of hargadi positive charge haira negative charge haira haibaduni greater than 0 of hargadi positive charge oidini and positive charge oirgadi sigi figure ji yakadongni abo less than 0 of hargadi negative charge haine abko 0 di pick by the negative value la ani aduna negative charge haibi mahuta less than 0 na harakta di sigi figure ji yakadongni abo next property number 2 da laji Roman number 2 the electric field lines singse kakna ba yadi aba electric field lines singse kakna ba suya yadi haibani aduna intersect to ba yadi aduna my properties is mani ba yai two electric field lines cannot intersect each other electric field lines ani kaidong disu kakna ba yaroi maram karigino phai tardi amu yengsi magi reason je ko maram je karigino phargadi akoina sida figure ma yekseba smaina electric field lines ani khak si kakna re na lower seba electric field lines se amana e hairasi amana b hairasi these two electric field lines are intersecting at a point p sigi point p is kakna re lower seba atardi a haiba electric field line sigi a haiba curve se sigi point p da tangent nama e seba tangent nama yek targadi smai la ani curve e sigi tangent hargadi smai la doini tangent se point p da ko atardi magi definition ki matungina sigi point p za leiba electric field intensity je tangent gi direction chatkani haibani aw si smai na p rane akoina curve a je khanaragadi ko aduga curve b je mloroba curve b je lok tardi sigi same point jida tangent amu yek seba curve b da ko a nataba b haiba curve sida tangent yek tardi smai la kani sidasu electric field intensity ki direction se tak tuini se sina e dias hairje audi sub manaba point sida electric field intensity ki direction se ani thola ne ba amana e vector hayama amana e dias vector hayama aduna sub manaba point da at the same time da electric field intensity ki direction ani leba yadi ba ko aduna ani leba yadabanina electric field lines sing se kakna ba yadi na khoina haidui ne ba adu magi maram je smai iba yai sigi property number 2 gi magi reason je when two electric field lines are intersecting at a point, then two different tangents can be drawn at the intersecting point. This shows that two different electric field intensities exist at a point which is not possible. Oithukpa yadi haibani aduna electric field lines ani kangnaba yadi haibagi maramduni sida khoina pirise ko property number 3 da mulaji property number 3 Roman number 3 da laktuise akhoina electric field lines singse lengthwise moise contract togone aduga next property number 3 da laktuisna electric field lines singse moise lengthwise contract togone mokhoi length se yaring tension abo honagane aduna maram orkanda akoina unlike charges attract each other haija explain to boya abo ko akoida rubber ama chingtok targadi rubber gi length se tension abo khonari dana almai to dana electric field lines su magi length se yaring kai tension abo masa gi no khona jai abo ko aduna by property number 3 just minus pirani electric field lines tend to contract lengthwise. Electric field lines tend to contract lengthwise and hence unlike charges attract each other. Unlike charges attract each other. Sigi property number 3 jakoina figure oina hype yek thokpa yai smaina doini positive charge amaga negative charge amaga lawraba adu tardi negative charge tagi lakpa electric field lines to magoda ki thoraka doini adu negative charge ma sangi ne basmaina negative charge ma sangi ni smaina smaina yek pa yai adu tardi sida le riba electric field lighting se makoi gi asang ba je leng se yaring kai shorten tawna ba tension na ba ko hona je aduna si tension na ba ko hona rakpani na plus q ga minus q ga je singjan na rakani na koina explain to ya ko then property number 4 da law to is na electric field line sing se makoi gi nakan hai tare side ways repulsion nakan ithok na ba ko hona ba electric field lines sing se makoi gi matai hai tare ko nakan ithok na ba honai aduna maram or kanda koi like charges se repel tawi hana koi explain to yai on the property number 4 das by not be yai Roman number 4 the lak tu is electric field lines tend to exert lateral pressure, that is sideways repulsion, and hence like charges attract, like charges repel each other. Smaina. Ado sigi property number 4 je akoina figure oina yekthoke haragadi smaina akoina yekpa yai. Sida plus charge ani leiraba like charges hadiko plus charge ani leiraba positive charges altadi positive charge dagi di electric field line je tholakadoi tholakpa ngakta ni aduga muk tholaiba line ani je kaknaba yadi sida tholakpa line se somdagi du tholakadoi ni si ani je kaknaba di yadi aduna moi je kamai sakhi gebu smaina sakhinebu somda su smaina lakpa yai smaina si sakhidoi ne smaina adoi tardi sigi property gi matungina smaina leidoi ne sagi line just smaina leiragadi electric field line smaina leiragadi si matai ani inthokna ni haibani sida man hairi je exert lateral pressure ibdi sideways repulsion nakan ji inthokna ni haibani aduna sida leiriba sigi electric field lines ani ji mark sida ju inthokna rakane smaina pressure ma lakane smaina inthokna rakane aduna maram orkanda like charges se repel tawi na haibani. Next time yengsi sigi point number 4 yagore point number 5 amuk laksi property number 5 ta laktu ji nang sagi electric field intensity je magi mapanga je strong oivra weak oivra is kari da lekwibu sagi number of electric field lines per unit area ko sagi area akoin akakna ba area margani adugi area to the far saliba electric field line sing do adugi masing hai tare adugi to maka pole haidi electric field line se yam nang na leiraba yam kung na leiragadi crowded oiragadi electric field intensity je strong way na high neba aduga weak oiba jaga de moi je lap na lan leigane ba aduna smaina property number 5 ta smaina pi ba yai electric field lines are closer apart. Yam dang ni have ni ko crowded ko closer apart in the region of strong electric field. And they are farther apart in the region of weak electric field. Now electric field intensity or simply electric field mapangan kanba jaga dadi electric field line sing je yam nang na laigani aduga electric field intensity son ba jaga dadi makoi sing je lap na lei haibani. Next property number 6 ta laji property number 6 ta lak tu jina electric field line sing se khoi gi material je force pangam de aduna material manung da electric field je khoina zero le na loba yai. Ada property number 6 ta khoina ibya is electric field lines cannot pass through conductor or material ko now and hence electric field inside the conductor is zero. Conductor manung da electric field laiteu property number 7 7 da to jina electric field line sing se akoina insulator da di for se pangabi ana property number 7 the EBR is there electric field lines can pass through insulators. So these are the common properties of electric field lines. I hujik hai gim sing do hyper remind toge ahan ba point da man hari se electric field line sing se positive charge oragadi positive charge tagi magi direction je thorakani haibani negative charge oragana electric field line sing se negative charge from the sangje lakani haibani property number 2 da hairjana electric field line sing se amaga kangnaba yade intersect toba yade haibani aduga property number 3 da pijina electric field line sing se makoi gi lengthwise contract togani makoi gi length se yarigi tenjanaba honagani aduna maram orkanda sagi unlike charges sing se attract togani haibani aduga property number 4 da hairjina electric field line sing se sideways repulsion that is lateral pressure legani nakan itolagani aduna maram orkanda khoi like charges se repel tawi haibani aduga property number 5 ta hairjina electric field line sing se yamna nangnaragadi strong electric field way aduga lamla leragadi weak electric field way in haibani property number 6 ta pirijina electric field line sing se khoi gi conductor or material sing the force pangamde aduna maram orkanda electric field inside the conductor je zero way haibani adu property number 7 the pirijina electric field line sing se insulator di force pangami haibani masini khoi gi electric field line sing gi maru oiba khoi gi property sing se ko ana sigi property sing jidagi exam da lakpa yaba question khara sar haige yengsi ko adu question is maina lakpa yai write any 3 properties of electric field lines mai nang bayai bagi marks se hoina 3 mark kum da pir bayai ko property ahum mi bagi next no to electric field lines no two electric field lines can intersect each other. Give reason or why. Reason piun hang bayai it may 2 mark oi bayai smaina ana electric field line sing se kangna ba yade maram piu haibagi 2 mark mere adu mai property sing masagi mari yu hai bayai ahum yu bayai smaina dum hang bayai sina sagi common question hai tare exam da ko hang bayai ba question ni sigi ani sim ko